Okay, so these are the two problems that you guys asked about, that you needed me to go through with you guys. Okay, so our first term is -2. The second term is 5. And I want us to get through to the sixth term. So my third term, so n is 3 in this case, is equal to 3 times a sub n minus 2. Since n is 3, I have 3 minus 2 plus 4, a sub 3 minus 1, which really works out to be the first term plus 4 times the second term. So that simplifies to 3. My first term is -2 plus 4 times by my second term, which is 5. And I'm going to use my calculator. And I get 14 for that. So if you look at this, I'm using 2 previous terms plus 1 previous term. So my fourth term is going to be 3, 2 previous terms. So 4, 3, 2 plus 4 times a, the previous term to the fourth term. So that's the third term. So that's going to be 3 times my second term is 5 plus 4 times 14. And I bet you these are going to end up being some pretty big numbers. I got 71 here. And then the next terms are just continuing from there. So second term, notice how I'm really increasing by 1. So I have the third term and then the fourth term. So I have 3 times my third term, which is 14, plus 4 times my fourth term, which is 71. And I typed something incorrectly in my calculator. I get 326. Now my sixth term is 3 times 2 terms previous, so my fourth term, plus 4 times by 1 previous term, fifth term, 3 times my fourth term is 71, plus 4 times the previous term. So 3 times 71 plus 4 times 326. And I get 1517. Okay, so you guys asked about this one. And again, in this problem, I'm using this y equals y sub 0 e to the kt formula. And exponential growth, so k is technically should end up being positive. So what I need to find for part A is the information in A, and the fact that I have 60 cells initially is going to get me my value for k. So after a certain amount of time, I have 75. 60 e to the k times by 30. Okay, so I divide by 60 and I get 1.25 is equal to e to the 30k. ln of 1.25 is equal to 30k. So I divide, so ln of 1.25 divided by 30. Ooh, that's a really small number. 0.0074. Now what I again like to do is I'm going to store that answer as some value. I'm going to store it as x in my calculator. So I'm going to store it as x. For part B, how long until the bacteria doubles in size? So if I had 60 cells initially, I want to know how long until I have 120 cells. 60 e to the k 0.0074 t. So really that's equal to 2. So ln of 2 is equal to 0.0074 t, and then dividing. Now what I'm going to do is I'm going to use this x value. So in my calculator, I am literally typing in ln of 2 divided by x. So I get 93.1885. And then part C is how long until there's 150 cells. And it's this same process. So I divide 150 divided by 60. ln of 2.5 is equal to 0.007474. I got too aggressive. I was thinking about my t. So t equals, again, in my calculator, I'm putting ln of 2.5 divided by x, and I'm getting 123.1885. So that's how you do the two problems you guys asked about. If you watch this, I hope you guys have a good spring break.